Okay, so 2.3 is about equations with linear functions. So that is definitely something that you guys did in Algebra 1. There's going to be a few new things that we're doing today, and then a few things that are going to be review for you. So one thing we're going to do is write equations in standard form, and standard form is not used a lot. Okay, so that's going to feel new, and then we're going to create linear equations in slope-intercept form using the coordinates of 2 points, and then we're also going to create equations in point-slope form using 2 points, and this should be review as well, okay? All right, so when you are working with linear equations in standard form, you are going to have them in the form ax plus by equals c, and then they give you some more stipulations here. So they say where a is greater than or equal to 0, a and b are both are not both 0, and a, b, and c are integers with the greatest common factor of 1. Okay, so if you are writing it in standard form, it does have to be in this order, where the x term goes first, the b term goes second, and then the c is the constant term. Okay, so the b is the coefficient of y. Okay, and so they gave you some restrictions. The first one they said is that a was greater than or equal to 0. What does that mean? If a value is greater than or equal to 0, what is it? Yep. So what type of numbers are those? Positive numbers, yeah. So those are just positive numbers. Okay, so a always has to be positive. Okay, if it's not positive, we're going to multiply by something that would make it positive. Okay, and then the next thing it says is a and b are both not 0, and they are integers. So what are integers? Whole numbers, yeah, and they can be positive or negative. Okay, and that includes 0 as well. Okay, so what you cannot have is decimals or fractions. Okay, again, we'd have to find something to multiply by to get rid of that. Okay, and then the last thing, it says the greatest common factor of 1. So if the GCF is equal to 1, that means those values are not divisible by any value besides 1. Okay, so an example would be, like if you had, you don't have to write this down, but if you had like 2x minus 4y equals 8, right? What goes into all of those? 2. So if you can divide all of them by a number other than 1 and reduce it, you would have to do that. Okay, so this one would be standard form, this would be standard form. Okay? All right, so we're going to write each equation in standard form and then identify the A, the B, and the C. Okay, and again, we're this is another no calculator section. There is one where you have to deal with decimals, and I am going to let you use your calculator on that one. Okay, so the first thing you want to do is have it in the proper form. Okay, so you want to write it in the form ax plus by equals c. Okay, and the x and the y have to be on the left side. Okay, so I want you to move a term over so that the x and the y are both on the left side. Move a term over so that the x and the y are both on the left side. Okay, so think about what you would do and then move it over. Okay, so Landon, what'd you move over for this one? Nice. Okay, so we're going to subtract over the y term. So then I have negative 0.2x minus 2.1y equals negative 1.9. Okay, now from there, we're going to make sure that a is positive. So we want a to be greater than or equal to 0. Okay, and we want all of a, b, and c to be integers. Okay, so we have to find something to multiply by to make this happen. Okay, so to make a negative into a positive, you would just multiply by what? Negative 1. Okay, in this case, let's analyze all of our decimals. All of our decimals are what place? The tens place. So what can you multiply by that's going to move that decimal over? Yep. Okay, so if you have the tens place to move the decimal, multiply by 10 to move the decimal one place. Okay, and I know some of you already know that. So if it was 2 places after the decimal, you'd multiply by what? 100. Okay, and then so on and so forth. All right, so we are going to multiply by negative 10 because the first value is a negative. So that's why we can do those together. So you're going to show your multiplication, what you're multiplying by. So we're going to multiply both sides by negative 10. Okay, and you do have to distribute. So what that's going to do is it's going to move this over, and then a negative times a negative is a positive, so you would have 2x. A negative times a negative here is also a positive, so if you move that decimal over, it becomes 2, 1. Okay, the decimal is now at the end, which makes it the whole number. Okay, and then we're going to check the GCF. Okay, so we just have to make sure that there's nothing else that divides into it. Okay, so see if the GCF is equal to 1. Okay, so is there a number that goes into 2, 21, and 19? No, and 19 is prime, so we know that that's it. So then you can just find your A, your B, and your C. Okay, so yep, I don't have to divide by anything. Okay, so then this is your final answer. Okay, so that was an example with decimals. Our next example is going to have fractions in it. So again, you want it in this form, the ax plus by equals c. So when you are moving things around on the same side, just remember that you are going to keep them with the symbol in front. So it would be negative 3/7 x. Okay, the y is a positive, so it's plus 2/5 y. Okay, but then this gets moved over. So when you are moving something over the equal sign, okay, you have to add or subtract it over depending on the value. Okay, now to undo a fraction, to make it a whole number, okay, if we wanted this to not be a fraction anymore, what would we multiply it by? 7. We multiply this one by 5, and this one by 9. So because we have different denominators, we're going to have to multiply by the LCD. Okay, so we're going to multiply by the least common denominator, which is formed by multiplying all of those together. Okay, so when you're doing this, just do 7 times 5, which is 35, 35 times 9. When you're doing 35 times 9, been talking about this strategy a little bit, right? Just break 35 up to 30 and 5. What's 9 times 5? 45. What's 9 times 30? 270. And then you can just add those together, okay? Which is the same thing if you were doing old school multiplication, right? Okay, now because this is negative here, you want to multiply by a negative. Okay, if it was positive, you multiply by a positive. So what you're going to do is you're going to multiply both sides by negative 315. Again, we're doing that because we want the x value to be positive. Okay, but if you're like me, you are not going to want to multiply 315 by 4 and then divide it by 9 without a calculator. That's too much. So keep in mind, we found this negative 315 by multiplying 7 times 5 times 9, okay? I'm going to write it here and then I'll do it there. I just want to write it bigger. All right, so if I'm multiplying 4/9 times negative 315, okay? Instead of negative 315, let's think of this as negative 7 times 5 times 9. Because we agree that those are the same thing, right? 7 times 5 times 9 is 315. Okay, how would that help me out here? What could I do? Yeah, so if I'm multiplying by 9 and dividing by 9, don't those cancel out? Yeah, and then I know a negative times a negative is a positive. So then look, all I have to do is multiply 4 by 35. Okay, so if I'm multiplying 4 by 35, then I'm just saying, okay, 5 times 4 is 20, 4 times 30 is 120, and then there you go, right? Okay, so when you're multiplying, instead of the 315, we're going to think of it as 7 times 5 times 9. And you have the negative in front. 7 times 5 times 9. Okay, so if I'm multiplying negative 7 times 5 times 9 times negative 3 over 7x, and then in the second one, again, I have negative 7 times 5 times 9 times 2/5 y. And then I'm just going to write down what we just talked about. Okay. All right, so let's try it times this one. So again, we know a negative times a negative, that's going to be a positive, so we don't even have to worry about that. We're going to cancel out the 7 and the 7. So I'm just doing 5 times 9 times 3. So 5 times 9 is 45. If you're doing 45 times 3, okay, you can just add, what's 45 and 45? 90 and 45. 135, so you have 135x. Okay, and then I want you guys to try that middle one, okay? Okay, so what are you going to cancel? The 5. And then because you have a positive and a negative, you know right away it's going to be negative, so you can just change this. Instead of a plus, you can put a minus. I'll write it nicely in my next step. Okay, and then 7 times 9 is 63, and then this is just 63 times 2, right? 60 and 60 is 120, 3 and 3 is, yep. Okay, so then your final answer is just 135x minus 126y, and it's equal to 140. And it's okay that this one is negative. The only one that can't be negative is what? A. So A is the only one that can't be negative. Okay, and the GCF for all of these is 1. And one way that you know that is you canceled out what they had in common. Okay, here. And you found the least common denominator to get there, so there's nothing else, no other factors they have in common. Okay, and then example 2, you're writing each equation in slope-intercept form. This is review for you. So slope-intercept form means what? Y equals mx plus b. Yep, great. Okay, and then if you're identifying the slope and the y-intercept, okay, we know that the m is the slope. Do not take the x with it. The b is the y-intercept. Okay, one thing we do want to make sure we have is when we are simplifying is that we're reducing our values. So we're going to move the 10x over. We're going to divide by 2. The x term is always going to go in front. And when you divide by 2, you're dividing everything by 2. So this becomes negative 5x plus 8. This is your simplified form. Okay, and then your slope is negative 5. Your y-intercept is 8. And you can put b as 8 as well if you'd like. Okay, and then if you have fractions, it's going to be the same process. You always either add or subtract to move your x term over. So you have negative 1/3 y equals negative 4/5 x plus 3. So you are going to want to divide by negative 1/3. It's going to be a lot simpler if you use the what? Reciprocal. So what's the reciprocal of negative 1/3? Negative 3. Okay, so we're going to multiply each side by negative 3. Okay, so the 3's cancel. A negative times a negative is a positive, so you have 1y. Okay, when you multiply here, you can think of it as over 1. So a negative times a negative is a positive. Okay, a positive times a negative is a negative. And then you have your slope and your y-intercept. Okay, now we're going to take what we know about linear functions and we're going to start to explain these parts. So what does the slope mean in a situation? What does the y-intercept mean in a situation? So the linear equation y minus 12x equals 25, that describes the cost to rent a kayak at the East Bay Paddle Company. It says where X is the number of hours a person uses the kayak and Y is the total cost of the rental. Okay, so you have X, and that is the number of hours the person uses the kayak. That is your input. Your output is Y. That is the total cost of the rental. And then they are asking you to do several things here. First is writing the equation in slope-intercept form. Then we're going to interpret the parameters in context of the situation. So we know that whenever we're doing any type of interpretation, we want a complete sentence that includes units specific to the situation. Okay, we're going to include those units specific to the situation. Okay, so let's start off with the writing the equation in slope-intercept form. That'll be our first task. Our second task is the interpretation. So we are given y minus 12x equals 25. So we will add 12x to both sides to get that in slope-intercept form. Okay, and then for step 2, we're going to talk about the y-intercept and the slope. Okay, so the y-intercept, when we were solving or when we were writing interpretations in chapter 1, do you guys remember what we'd always use when we were talking about the y-intercept? Yeah, this is your initial value. Okay, and then your slope is going to be, in this case, increasing. Sometimes it's decreasing. It's going to be an increasing value, okay, or increasing units. The slope is what it's increasing by every cycle or decreasing by. So in this case, we know our y-intercept is 25, but what does that mean in context? What are the units? Yeah, right. Yep, so it's a $25 initial cost, okay, or you could call it like a base fee. Okay, to rent. So no matter what, you're getting charged $25. Okay, our slope is 12. What does that represent? Yes, so on top of that, it's going to be the $12 per hour. Good. That you're using the kayak. Okay, so now we just have to lead that into a sentence about this context. Okay, so because the y is the total cost of the rental, we can start by saying the cost of renting a kayak includes, and then you can say like a base fee or an initial fee. Okay, so the cost of renting a kayak includes an initial fee of $25 plus an additional $12 per hour. Okay, so when you're doing this on your own, like you're thinking about this, right? 25, okay, $25. So that's our initial fee, it's $12 per hour. Okay, that's how you're gonna weave it into a sentence there. All right. Example 4 is another story problem. This is one where you can use your calculator because there are decimals with that. So I'll give you a moment to read through, and then if you want to highlight or underline anything that's important. Okay, so we know we're dealing with the amount of rain. How are they measuring the amount of rain in example 4? Okay, so we have the 11.5 millimeters, that's part of it, and then this is the 16.7 millimeters. Okay, so the rainfall, that is our output. Our input is what? The what? Yeah, your hours, okay, so the time. So for this, we have at 1 p.m., we have the 11.5. Here we have at 5 p.m., it's the 16.7. Okay, and then I just put a little calc by this because this one you're going to have decimals, and if you have like several decimals, I'm going to let you do that with your calculator, okay? All right, so in example 4, it says at 1 p.m., the meteorologist records a total rainfall of 11.5 millimeters for the day. After continued rain, the total rainfall at 5 p.m. is 16.7 millimeters. We're going to define variables to represent the situation, find the slope and y-intercept, then write an equation, and then estimate the total rainfall for the day at 10 p.m. if it continues to fall at this rate. Okay, so what is happening here is we want to estimate rainfall Okay, we want to estimate the amount of rainfall based on the time of day. Okay, so it's not like, oh, after 10 hours yet, because all we have to quantify the output is the time it occurs. Okay, and of course, when we do this, we're going to be using our units. So whenever you're defining variables, you can always start off with let x represent, let y represent. Okay, so our x is going to represent the number of hours. The rain falls. Okay, so we're going to have to do some calculations to get there, because right now we only have the time of day. And then we're going to let y represent the total amount of rain in millimeters. Okay, so this is going to be a two-step process. So in order to find the slope and the y-intercept, we are going to have to use the data we have. And right now we know that it starts at 1 p.m. and we have 11.5. What we're going to do is we're going to turn that into a coordinate point. Okay, so your coordinate point is going to be 1, 11.5. Okay, we also know that at 5 p.m. it's 16.7. Okay, so at 5 p.m. it's 16.7. So you can create data points based on the information they give you. And then we're going to use our slope formula. In science sometimes, do you guys use this delta symbol? Do you know what the delta symbol represents? Yep, so it's the change in y over the change in x. Now when you're doing the slope, you're used to writing out y2 minus y1 over x2 minus x1. So if you create these points, then you can use your slope formula, okay, to identify your equation. It doesn't matter which one you call x1, y1 and which one you call x2, y2, as long as the ones are together and the twos are together. Okay, so we're going to do 16.7 minus 11.5 over 5 minus 1. Okay, and so remember, I'm going to let you use your calculator on this one. So the difference, the change in y is 5.2. Okay, the change in x is 4. I guess technically you could do it without, but I'm not going to. Do some of you know that 4 times something is 52? Yeah, so it's 1.3. Okay, so this is your slope. Okay, now your starting value, okay, it starts at 1 p.m. That means that your starting value is 11.5. This is your y-intercept. And I know that feels a little strange right now because normally with your y-intercept, right, you think, oh, you plug in 0 to get it. Well, you will. It's just you have to use these quantifiers to find out what your slope is. Okay, so your equation is y equals 1.3x plus 11.5. Okay, so if you plugged in 0, your starting would be 11.5. Okay, so if we're estimating the total rainfall for the day at 10 p.m., if it continues to fall at that rate, let's think about what this equation represents. So at 1 p.m., you'd plug in x is 0 because that's your starting point, right? Isn't that how we would find y is 11.5? By plugging in 0? So 1 p.m. is our starting point. Plug in 0. That's how we get the initial value of 11.5. So if I wanted to find out what the rainfall was at 2 p.m., what would I plug in for x? 1. If I wanted to figure out what happened at 3 p.m., I would plug in x's 2. Okay, so if I want to figure out what it is at 10 p.m., what am I going to do? Yep. Okay, so at 10 p.m., x is going to equal 9, and that's how you can find your final answer here. So 1.3 times 9 plus 11.5. Okay, so you can go ahead and calculate your value and then make sure you include your units with that. Okay, so we'll do 1.3 times 9 at 11.5. Okay, and you should get 23.2 millimeters. You can also just check and make sure if you know at 5 it's 16.7, this value should definitely be larger than that. Okay, and then do you guys remember what your point slope form equation is? The point slope starts with y. Y minus y1 equals m x minus x1. That ring a bell? Okay, so that is where x1, y1 is a point on the line. So you don't plug anything in for x and y. Okay, and your m is your slope. Okay, so for example 5, you're going to write an equation in point slope form for each line that satisfies each set of conditions. So the slope is 0, it passes through negative 2, 8. This is your x1, y1. Okay, so when you substitute, it's going to be y minus 8 equals 0, x minus negative 2. Now the only thing you have to simplify is if you have minus a negative, because minus a negative is what? Positive. So anytime you see a negative, you can just jump right to this step. Okay, you won't have to show any work for these. You can jump right from here to here. Okay, all you're doing is substituting. No simplifying. Okay, so then can you guys do part B? All right, let's see if you got it right. So you'd have y plus 2, because minus a negative is going to be plus. Okay, and then your slope is 3/8. And again, you don't have to simplify anything if it's in point slope form. Okay, so your slope is your m. All right, do you guys remember that from algebra 1? No. Okay. Then we are going to write an equation. Again, it's in point slope form. And this time you are given the set of points. So just like we did earlier, we are going to find the change in y over the change in x. So we're going to do y2 minus y1 over x2 minus x1. And you guys probably did this in geometry, right? Okay, so you have 9 minus negative 7, which is going to turn into plus. 13 minus negative 3, that turns into plus. And then anything divided by itself is 1. And if they ask you to do it in point slope form, there are really 2 correct answers. You just have to write one of them down. So if you use the first point, it's y plus 7 equals 1 times x plus 3. Okay, if you use the second point, it's y minus 9 equals 1 x minus 13. Okay, so you can choose either one of those. Okay. All right, and then go ahead and do part B. Okay, I'm seeing a few different answers for the slope, so let's make sure we're all on the same page. So we're doing -2 minus 6, and then -5 minus -3, which is going to turn into a +3. Whenever you have minus a negative, it'll be a plus. So you have -8 over -2, and what does that produce? +4. Okay, so that should be your slope. Okay, so make sure you're writing this out for me, please. And then again, you have your choice. If you use the first point, then your equation will look like this. And if you use the second point, your equation will look like this. Okay, so you get to pick which one of those you would like to use. All right, now we're going to apply this strategy to a real world situation. So there's a popular sandwich shop that sold 174 subs by 8 p.m. By 10 p.m., it sold 290 sandwiches. We have to write an equation in point slope form that represents the number of sandwiches the shop sold after it opened at 5 p.m. Okay, so there's another piece of data there. Okay, so if it opened at 5 p.m., this is your starting time. Okay, we know that our input, our x value, is going to be the time. Okay, and it's in hours from the start. Okay, so the start, which is 5 p.m. Your y is the number of sandwiches or subs that they made. Okay, so then what we have to do is create a set of points here. So we're not going to use 8 p.m. because we have to calculate it from the starting time. So if it started at 5, how many hours has it been since 8 or to 8? 3 hours. So your data point would be after 3 hours, 174 subs were made. Okay, and then for the 290, that was at 10 p.m. So how many hours have passed since that? 5. So these are the two data points you're going to use to calculate your slope. Okay, and again, it really doesn't matter what you use for the x1, y1 as long as you're consistent. So if you start with 290, you're going to start with 5. Always put the minus there. Okay, and then you have the 174 over 3. Okay, so you'll get 116 divided by 2, and you'll have 58. So that represents how many subs they can make per hour since they opened. Okay, so again, you have two options. If you use this data point, it would be y minus 174 equals 58 times x minus 3. Or if you use the second point, y minus 290 equals 58, x minus 5. All right, I'm going to put out of your assignment, and then if you are going on a field trip tomorrow with